Hello and welcome to today's webinar. I'm Kevin Westerling, Chief Editor of Water Online. Thank you for joining us for this presentation, Enabling Smart Cities and Water Utilities, Leverage Infrastructure with Data Intelligence to Power Your Water Network. We have two presenters for you today. We will be joined by Dave Johnston, Director of Smart Infrastructure Water Products, as well as Hannah Lindsay, Product Owner, also with Mueller Water Products. Together, they will discuss how data from your existing infrastructure network can provide valuable insights to help power critical decisions about your operations, asset management, and maintenance programs. Before we get going, let's briefly discuss technical information. If during this event you experience technical problems, take a moment to refresh your browser and see if that resolves the issue. If your problem persists, please submit a question via the Q&A system and we will help you diagnose and resolve it. If you have a question for one of the presenters, please submit it through the Q&A system and we'll answer as many as we can at the end of the presentation. At this point, I'd like to turn it over to our first speaker, Dave Johnston of Mueller Water Products. Dave, the floor is yours.
Thank you. And welcome everybody to today's webinar. Thank you for taking the time this afternoon to take interest in this content and what Mueller has to present to you today. And so there are four of us available today for comments and questions. I'll be, myself, Dave Johnston, will be presenting the main content. Hannah is going to walk us through a software demo towards the end of the session. And then both Harold and Patrick Nine are here as subject matter experts to answer any questions that the audience might have at the end of the session. So from today's presentation, the takeaways that we would like you to leave the presentation with is a little bit of an understanding of the drivers behind why utilities are needing these smart technology solutions. I'm going to talk briefly about the Mueller philosophy around new product development and technology innovation, and that's sort of rooted in those driving factors that I mentioned. We're going to talk to you about four of our new smart solutions. That is Centrex, which is our software platform, EchoShore DX, a leak detection product, HydroGuard pressure monitoring, and our water metering product portfolio. And really, the whole idea there is that all of those products are now tied into Centrex, our software platform. And then we're going to talk about what's next for Centrex and what's next in the Mueller technology portfolio. So first, why do we need innovation and these technology solutions? Well, there are certainly external forces and internal forces in water utilities that are driving the need for innovation. One of the papers that I tend to go back to a lot is one by Stephen Folkman, Water Main Break Rates in the USA and Canada. Very interesting read because it shows this exponential increase in the rate at which pipes are breaking in North America. And so overall, that's up 27% in 6 years. And when you dig into the data, it's very suggestive that, we as utilities are not doing the right things to control the degradation and the deterioration of the water networks. Because if we were, then we wouldn't be seeing an exponential increase in the break rate. And the thing that I find really interesting about this is that when I look at spending in the water utilities, we see this increasing trend in operational spending. So over a 20-year period, it's on a steady uptick. But you see that capital spending has sort of flattened out and even decreased in more recent years. And this is perplexing to me because capital investment is there so you can improve the operating lifetime of your utility. So anytime you're going to dig in and replace a pipe, you want that to be the right pipe, and you want to make sure that the life of the utility overall has been extended as a result of that investment. And it doesn't seem to me like those decisions are being made in a way that is extending the life of the utility. And as a result of that, operational spending is increasing to continue supporting an infrastructure that's failing. And so it's a little bit perplexing to me, but I think, and my theory is that capital investment decisions are not being made with the right information. And we're putting those capital investments into the wrong places of the network. And so it's one of these driving forces that we really think justifies the need for better data and better insights into what's going on in the system. And so with that, we're going to shift to a poll question. And so if the audience could just respond yes or no to this, is your utility experiencing increasing operational expenditures and decreasing capital expenditures? Okay, so I'll give everybody maybe 20 seconds to answer the poll question. From my view, I hope that this is up in front of everybody right now. Okay, so let's take a look at the results, and that's pretty interesting. So it does look like that utilities are generally feeling what the trend is showing overall. I do know that utilities vary across North America. There are newer utilities and older utilities, and some areas that probably make better capital investment decisions than others. So we do expect some variation in there, but it looks like the trend that we see on the macro level does translate well to what's going on a case-by-case basis. So thank you for that feedback. Some other external forces that we know are influencing the need for innovation. So this is a little bit of analysis that I did recently, just sort of out of interest as to what non-revenue water might be contributing to the issue of climate change. And so there's a few different sources for this, but in the USA alone, non-revenue water equates to about 2.1 trillion gallons of water loss on an annual basis. And so that's water that is treated and pumped into the network, and that doesn't actually flow through the meter as a billable revenue generating item that the utility can make money off of. And so it's generally lost as leakage. 2.1 trillion gallons per year. With some computation, I can take a look at what this actually means from a carbon footprint standpoint. And it's actually about 500,000 tons of carbon footprint, CO2 equivalent on an annual basis. And that is approximately the same as about 184 million trees. It's greater than 750,000 cars, about 712 wind turbines, or 6.2 billion kilowatt hours of electricity generation. So it really surprised me to take a look at it like this. And I think the industry as a whole doesn't really realize that we can make such a big impact to carbon footprint just by managing water systems a little bit better. So that 2.1 trillion gallons is actually, I think it's between about 10 and 30% non-revenue water on a utility by utility basis. And so, just imagine if we took that average of between 10 and 30% and took it to maybe between 5 and 15%, that it would have a massive impact on carbon footprint, and also would wildly improve the utilities' revenue generating machine quite a bit. So all these external forces, along with other forces as well, there's, we could continue to talk about different driving factors that are driving the need for new technology. But these are the things that Mueller and the team that I work for, the new product development team, use to determine what types of products we're going to bring to the industry. And Mueller as a whole, we're an old company. We're about over 160 years old now. We're generally known as a fire hydrant company, a valve company. But we have recently changed our philosophy around new product development, and we're thinking more like a startup. So maybe the attendees have heard of this term before, but we're using the agile development philosophy. We are trying to fail fast, trying to make sure that all the products that we make are a result of true customer needs. And so if you're a customer of ours, you may have participated in some recent working sessions that we've done where we really try to understand the customer problems and those external forces that are driving the need for change. And all of that, hopefully good research that we're doing is translating to very specific new product development initiatives, some of which I'm going to introduce to you right now. So the first that I want to talk about is the new Sentryx software-enabled Super Centurion fire hydrant. And so this is, my slide has jumped back on me here. So this is one of the newest products in the technology portfolio for Mueller. It is based off of the Super Centurion fire hydrant, which is probably one of the most well-known fire hydrants in North America. The fire hydrant traditionally has been known as is sort of this, it's this thing that's on everybody's street and nobody really recognizes it except for the dog and the fire department if they have to show up if there is a fire. And so it's this health and safety device that lives out there. And for over 100 years, this device has only been there for the purpose of putting out fires. The water utility has also used it to, maybe do some flushing activities and help maintain the network. But the purpose of the fire hydrant is to protect the life and safety of homeowners in the case of a fire. Mueller, we're transforming the fire hydrant into something that does more than just protect households from fires. We want it to protect households and homeowners from water quality issues. We want it to protect utilities and help utilities manage their system better. And so we're really trying to transform the fire hydrant into something that is much more than just a health and safety device. And so the new Super Centurion fire hydrant has in its bonnet at the top, it's got a gateway board, which includes a cellular modem, a GPS chip, and a battery pack. It's got a Bluetooth connection that communicates down through the barrel of the fire hydrant to a HydroGuard pressure monitoring device. That pressure monitoring unit is designed in such a way that the fire hydrant can measure the pressure in the system, in the water pipe, while it's in its closed position. And so typically the Mueller Centurion fire hydrant, it's a dry barrel fire hydrant. That fire hydrant lives its life in the closed position unless there's an emergency or unless there's a flushing activity happening. And the way that this is designed, it will read the pressure in the closed position. And so typically other technologies, if you're going to install something on the fire hydrant to measure pressure, you actually have to open the fire hydrant up, you have to pressurize it with water, and you have to leave the device mounted to one of the ports to measure pressure. And that there's lots of problems associated with that because, well, one, if the fire department shows up to use the device, they've got a pressurized fire hydrant on their hands, and that's going to be a little bit of a surprise for them. But two, it's if there's a freezing event, then you don't want water up in the barrel of the fire hydrant. That's gonna create some damage. And so this is a revolutionary way to have pressure from the water pipes without having to pressurize the fire hydrant. The new Super Centurion is also available with EchoShore DX leak detection. And so Hannah's going to speak briefly to this when she does the software demo. But that is a device that listens to the water network for leaks. And if a leak appears anywhere on the water pipe, not just on the fire hydrant itself, the EchoShore DX technology will tell you that leak exists and tell you where that leak is within less than a foot worth of accuracy most of the time. And so it's very, very good technology and works really well with having pressure measurement as well. And so we're all, water utility people here. A big leak can cause a pressure drop, and a pressure drop can cause water quality issues. And so knowing, one, that there was a pressure drop, and two, that there was a leak that's likely the cause of it, and three, we know what the pressure is, and if there was a potential water quality issue, are all things that we can get from this fire hydrant now. Now, I did mention we have a cellular modem. All of this data is relayed over the 5G cellular network and back through whatever service provider it might be, Verizon or AT&T or T-Mobile, back through that service provider network onto cloud server infrastructure where you can access the data from the Centrex platform, which Hannah's going to demo. So it's a very exciting product. We think it's a coming together of a lot of different technologies that Mueller has in the portfolio, and definitely revolutionizing the fire hydrant and making it much more than just a fire hydrant. Now, I want to talk briefly about metering too. Mueller is a metering business. Mueller Systems has been a business of ours for a while now. And these meters communicate over proprietary AMI networks. And we have now introduced meters into the Centrex platform as well. So, going back to the Centurion fire hydrant, here we're bringing pressure data and we're bringing leak detection data into the Centrex platform. We're also bringing water metering data into the Centrex platform. And so the water meter itself, our newest version, is called the remote disconnect meter. And so it's got a traditional positive displacement meter body style. It's got an AMI node on it to bring the data back over an RF network into a collector and then into Centrex. And probably the coolest feature of this is that it's got a remote disconnect valve on it. And so what that means is from Centrex, from the software platform, you can actually send a disconnect command and shut a valve at the water meter itself. And so this is one of the newer, more exciting products that we've got in the Centrex lineup. And we have had some, recently some pretty big sales with this product. And we've got a lot of excitement around the fact that you can close the meter without sending a truck to the field. And so areas where there's a lot of, transient living spaces, so college towns, military bases, or areas where you might have a high occurrence of non-payment on water bills. This has been a really exciting technology to have out there, and it's one of the only examples in the market of having actuation control out in the water distribution system. Okay, with that, we're going to shift to a demo from Hannah, so the audience can take a look at exactly what the Centrex platform looks like.
All right. Hi, everyone. Can everyone see my screen? I just want to make sure it's up. Oh, I think it's up now. All right, perfect. So, hi, thanks, Dave. Hi, everyone. My name's Hannah, and today I have the pleasure of guiding us through a really quick overview of Centrex. So, Centrex is Mueller's intelligent water software platform. This is the software platform that hosts all of Mueller's smart water products. These are things such as leak monitoring, pressure monitoring, water quality, as well as meters that Dave had brought up just a bit ago. You can see right now that this top ribbon shows all of the different products that we could have installed and are available on one site for us to look at. So these physical products are all installed in the field, and they're busy recording, they're capturing data, and then they're returning that data to our servers for analysis. So then in turn, we're able to display alerts, these insights on our Centrex platform. So these insights are things such as, go to this address because you have a leak here, flush your water mains as there's too much sediment, or adjust your pumps as a transient occurred. So the goal is to give actionable insights to users so that they can ask more intelligent questions and then make more intelligent decisions about what's happening in their water networks. So with our time today, I want to demonstrate one example where we can show leak monitoring as well as pressure devices working together. So right now I'm on our My Network tab, and this is where we could see our pressure and leak monitoring together. So first note that we have our entire water network mapped out. So this is not only important for our devices to gather data, however, it also gives us visual clues of where we need to focus our attention. Right now I'm going to hide this so that we can just focus on the leak alerts as well as the pressure devices that we can see. For this example today, what I'm looking for is I'm looking for a leak alert that's near a pressure device. I'm looking for this so that we could see a relationship between the two. So with this, I'm going to click on this pressure ID, and it's going to bring me to its details page. This details page is where we're going to be able to see a lot of this, or more of this device data, so that we can look further deeper into what's occurring. For this, so this is the details page. And what I want to bring our attention to today is this pressure chart on the side here. So right now we can see that this is looking at the some of the data that we can see in the last couple days. And what I want to do is open this up to show more data from the past. As this is loading as well, I want to note that on the right here, or on the left, sorry, we can see that there's a pressure gauge as well as some more information that's giving us a look of what else is occurring on the device. And we're also able to set up the schedules as well as look at some of the alert constraints down below. But going back to the pressure device here, or the pressure data in this case, we can see that there actually was a pretty big pressure change that started a couple months ago. So we could see that the pressure was operating at a pretty normal level. It drops down for a period of time and then climbs back up to a normal pressure again. This drop here is an indication that a leak may have been nearby during this time frame. So originally, when we were looking at this pressure device in particular, we were looking for a leak alert nearby. So let's go back up to the map here, where we can see our pressure device, and then we can look at the leak alert that's nearby. So let's look at this leak alert to see if there's more information, more of a relationship that we can make between this pressure device and this leak alert. So I'm going to navigate to that leak alert, and this is going to bring us to the leak alert details page. This is really similar. This is really similar to the pressure details page that we were looking at just a little bit ago. Basically, this is where we're able to explore more data that's occurring at this point. Right now, I want to bring our attention to this correlation strength chart. This is the chart where we're able to visualize the noise that is coming in from our sensors. With this chart, we can learn about this noise and the relationship with the pressure chart that we saw earlier. So this chart is displaying how much noise is occurring at this alert. Each of these dots here represents a recording. And what we can compare these recordings to is this red line here. We call this a threshold line. Any point, any recording that's occurring above that line could be considered leak noise. Anything below, like these here, could be considered background noise. What this graph in total is telling us is that there was some noise occurring for some time, a leak, and this noise has since disappeared, meaning that the leak was fixed. This compares perfectly with the pressure graph that we were just looking at. These points above this threshold line is related to the pressure drop that we saw earlier. When the pressure climbs back up, that's an indication that there's no noise, and we can see that right here with these points occurring below that threshold line. So here we can see that the leak was occurring, the pressure had dropped, the leak has been fixed, and then the pressure has climbed back up to a normal pressure. So here, this is a very small example of how we're able to learn more about what's occurring in your water network with multiple devices on the same site. So in summary, we're trying to give your team as much data as we can for you to make more educated decisions about your water network. So thanks, Dave. I'll pass it back to you now.
Excellent. Thank you, Hannah. And just to reiterate, what Hannah had showed there is we're seeing more and more examples of the benefits of having both pressure and leak detection data on the same interface beside each other. Those are two fundamentally different technologies, and both of them have their pros and cons associated with them. Pressure, for one, is really good at understanding if there's maybe a water quality issue or maybe pressure spikes, but it tells you nothing about where the root cause of the problem was. Where leak detection, on the other side, is really good at telling you exactly where a leak is, but it's not very good when it comes to very fast-moving events. So if you've got a burst where the pipe goes catastrophic immediately, the leak detection, the way that leak detection works, it actually won't catch that right away, but the pressure sensor will, because you'll have an immediate pressure drop. So when you've got both of them together, it covers off so many different types of failure modes. And we're learning newer cases almost every day now. So it's quite an incredible combination. Now we see that, call it symbiotic relationship with pressure and leak, and we're going to see it as we bring other technologies onto the Centrex platform. And so on the Centrex platform today, we have leak detection. It's commercially available, and we are in the process of releasing both pressure and metering on the Centrex platform. And then moving forward, we're going to continue bringing other sensors in. And so the opportunity for data fusion and data analysis and finding more of those symbiotic relationships is going to continue to grow. Now, Centrex overall is a platform where our strategy behind it is to basically, we want to connect the right people to the right sets of data. And we want to try to break down these silos that exist within organizations. And so when we go get customer feedback from people, we're told over and over again, even yesterday I was on with a customer, and their biggest concern is about data sharing and knowledge management in the organization. And so what we've seen happen over the years is, as these new computer systems are stood up, they've made the silos worse. And so you've got asset managers that live on their asset management platform, and they do that, and they make decisions on where they're going to invest the next big pipe replacement program. And that's what they use it for, and that's it. And then you've got field supervisors that, use work order management system and fleet management systems to, run their operations crews on a day-to-day basis. And there's no connection between the asset management system and the work order management system. So any information that's shared between those is done manually through word of mouth, through sharing of spreadsheets or something like that. And this has created a disconnect between asset managers, the planning department, and what's actually going on in the field. And so the other thing that we commonly hear is that when the operations team is deployed to go fix something, the information collected from the site during the repair didn't make it back into the asset management or GIS system. And so, right there are examples of these silos that have been created that are hindering the ability for utilities to close the loop, is what I call it. And so what we want Centrex to do moving forward, in addition to what it does now, is to close the loop between what the desktop models and the asset management systems are telling us with what's actually going on in the field. And we're going to do that by having good real-time sensors in the field that collect data and bring it back into Centrex. But two, having a really good interface with the field service technicians so they can, confirm or deny that what the planning department is telling them is correct. And that will allow us to continuously improve this platform and use technologies like machine learning or artificial intelligence to improve our insights and our conclusions that we make from all these observations. One of the things that we've realized at Mueller is that, and with the Centrex platform, is that too much data is a bad thing, especially if you don't have good insights and good methods for converting all of that raw data into actionable, conclusive insights. And so, we've got examples of in the past and even currently, but let's say, for example, if you scale up your pressure management system and you go from maybe 10 pressure monitors to 100, then I'm going to end up with 10 times as many pressure alerts that come into the Centrex system. That is not beneficial for the utility. And so Mueller is making big investments into the data sciences side of this to make sure that we're doing good data fusion and good work to convert large volumes of somewhat noisy data into small packets of concise data that is actionable for the planning department, asset managers, and engineers to make recommendations to field supervisors, so field supervisors can tell their water service technicians to go out and make a repair or make a change in the network. So more about what's next for Centrex. So right now we're in 2020 and Centrex was introduced this year. And so it's live and we are converting customers from legacy platforms to this new platform, Centrex. And so if you are a Mueller customer right now and you've got pressure monitors and you're using miwt.net, we will be converting you over to Centrex by the end of 2021. If you are a Mueller customer of our water meters and you're on MyHost, we will be converting you over to Centrex by the end of 2021. And so this year and most of 2021 for us, it's about doing the conversions and sunsetting old systems. In parallel to that conversion process, we're going to continue growing what's known in the industry now as a data lake. And that's sort of the newer buzz term for a data warehouse or a data store. But the point is that we want to get all of the data into a centralized repository that is searchable and queryable and easy for Centrex to display it to you, the end user, but also somewhere where data scientists can get in and comb through and look for new insights and new relationships that maybe we didn't know existed before. And so looking for opportunities to get those really high value insights that can give you the utility, the ammo and the tools you need to run your system more efficiently. In 2022, we will be introducing new IoT sensors to the mix. And so not going to go into exactly what those are, but there are new ones coming. And so again, more opportunities for new data and insights from the field. And then sort of continuing with data fusion. And again, the whole strategy there too is we want to convert that data into insights, which then translates to business value. And the ultimate goal with all of this is that we want to empower you, the utility, to respond to and fix failures fast. I even make the claim sometimes that I think it's possible with the way the technology trend is going these days to eventually not just respond to a failure quickly and fix it before it causes an excess amount of damage, but even get to the point where you show up to a failure before it happens. And so I think we're seeing the coming together of good good live monitoring systems and good predictive technology to the point where we're going to be showing up to leaks, before they happen and fixing it before any damage is caused. That's a big statement, though, and making no promises about it today, but I think the technology is going to take us there in the future. We want to empower the utility to get control of their NRW. And so I think it's unacceptable in the industry that we're between 10 and 30% NRW. It needs to be below 10% everywhere. There's no reason it shouldn't be. We want to empower the utility to automate your meter reading and service shutoffs. And there are multiple good value statements there. If you can automate meter reading, you can get more guaranteed on claiming revenue every month. And you can, especially in the world of COVID these days, nobody likes sending a crew out there if they don't have to. And with an AMI system and with the ability to do remote disconnect, you can get this meter data and you can actuate meters all from your desktop on your computer, from home, frankly, and many of us are working from home now. We want to enhance customer service. And so especially with the metering side of the business, we've got very good customer service tools. So if you've got your customers calling in with comments, questions, complaints about the quality of their service, we want to give you the tools to be able to field those complaints and give your customers the service that they need. We want to help you mitigate that ever increasing break rate. And so the leak detection technology is an excellent way to quickly respond, leak detection and pressure, let's say, to quickly respond to your most urgent breaks first. And then finally, and almost most importantly, we want to improve communications and data sharing between departments and break down those silos that have popped up over the years. And then that hasn't just happened in the water utility space. That's happened in many different industries. Okay. That brings me to the end of the formal presentations. I do see that we have some questions that have popped up in Q&A. So let's move to the Q&A portion of this.
Yes, absolutely. Thank you, Dave and Hannah as well. As you mentioned, we do have a number of questions submitted by the audience. So let's go ahead and start the Q&A. First off, someone starting with a quote, "Too much data is a bad thing," which can be sometimes. Do you have any machine learning that helps look at the data?
Yeah, I can answer that question. So yes, we do. We've I think currently we've got 3 different machine learning projects underway. And very soon, and I'm not going to speak to exactly what it is yet, because we still have to go through the sort of the marketing and the legal and the IP work to make sure it's protected. But very soon we'll be releasing our first commercially generated machine learning, call it Insight, onto the software platform. And so this is something that we're going to continue to leverage moving forward. Machine learning is probably one of the quickest moving areas in data sciences and sort of all technology innovation right now, to be honest with you. And there are lots of good machine learning companies out there right now. And even I'll call out a company like Amazon, for example. So we're partnered with Amazon Web Services. They host our cloud data infrastructure. They've got machine learning tools out there now, which basically you no longer need to be a PhD level data scientist to do machine learning. These tools, it's almost turning into like Microsoft Office of machine learning. There's machine learning apps that you can deploy. So we're very excited about that side of the business, and we're going to continue to develop and grow it.
Okay, great. If a city has your hydrants, can they fit with your sensor systems for pressure, leaks, and flows?
Okay, is that if a city has your hydrants?
Can they be retrofitted with the sensor systems that you've been talking about? I imagine.
Okay, I know the answer to this one, but I'm going to give it to Patrick to answer.
Mm-hmm. Yes, our smart tech retrofitted to our Mueller Centurions, the Super Centurions, in the 5.25 currently. You'll be able to. It's just like installing a new main valve. So you'll pull the stem. We have those available 3.5 or 6 foot, and they're on 1975 resin. We all that comes in and the bonnet gateway. Now, as far as the leak detection, that's just going to be a cap replacement, which Hannah knows more about that, but it's pretty simple. And I think you have to have a larger deployment than you would with the pressure monitoring.
Yeah, just to jump in there for the leaks, with leak monitoring, we manufacture a new cap, and we will match whatever threads you have in the field. So whatever you have, we will match that, no problem. Same with the nut on the front. So they're all custom made.
Okay, great. There was a follow-up which said, can Centrix be fully integrated into a city's operational cost structure and allow forward thinking for P&M of their infrastructure? Parts and maintenance, maybe?
Yeah, that's. I'll try and answer that one. That's a pretty broad question because you'd have to define what fully integrated means. But Centrix is an open architecture platform, and we do plan on and intend to offer API integration with, almost. I want to say almost any system that a utility might have. Now, of course, some utilities have their own custom-made systems, and some utilities have like out-of-the-box systems. Each of those integrations would look different, but the short answer is yes. The long answer is each case is going to be a little bit different.
Right. Okay. Can they capture a transient from the beginning of the transient event?
I'll default to Harold Mosley for that answer.
Thank you, Dave. The answer to that question is yes. Mueller has a unique process that we utilize in order to monitor for transients. We actually record everything, and then we filter the unnecessary data out. But and we're filtering at an extremely high rate. We're reading transients at 256 readings per second. And if a transient is detected either in the min-max average with a transient trigger mode or in the full-blown transient mode of 256 readings per second with no limitation on time, the system will look back in time at the event and capture the data points that started to show the transient to where it started to occur.
Perfect. Okay. How about, does the fire department need to do anything special when using the smart hydrant?
I can take that one, Dave.
Yeah, go for it, Patrick.
That's one thing that we focused on when designing this, is that it would be no different than using a standard hydrant. Many people may not even notice that it is a smart hydrant. It has slightly different bonnet, but everything else is in between. So fire departments will not have to do anything special.
That's Patrick. I'm sort of jealous that you got to answer that one. That's my favorite question.
All right, try this one on. What spacing is recommended for leak detection monitoring locations?
I could take this one. So our spacing for leak detection is going to be based on the pipe material and the pipe diameter that you have installed. The maximum spacing distance is going to be 1,100 feet. However, regular spacing is anywhere from 300 to 700 feet. Every installation, we are going to calculate this completely for you. So you're going to have a calculated acoustic distance, which will work with you and your team for node placements, but expecting between 300 to 700 feet.
Okay. Is Centrix subscription-based, or does it come with the hardware? Maybe separate questions.
So there is I don't know if subscription is the right word, but there is a reoccurring software service fee that is based on how many, I'll call it endpoints you have installed. And so per meter or per leak detection node or per pressure monitoring device, there is a reoccurring rate that you have to pay to support and cover the cost of the network provider fees, and then along with that, we, as part of that service, we offer network monitoring and Centrex health monitoring. And so we have a network operations center and what we call our leak operations center up in Toronto as well. But it's a team that's on standby monitoring your systems as a part of that service.
Okay, great. With the smart meter, how does that affect hydrant maintenance costs? The smart hydrant, I'm sorry. Yeah.
Smart hydrant. I'll go to that one.
As far as maintenance costs, your only difference between a regular hydrant and a smart hydrant is going to be your batteries and your bonnet gateway. So the batteries is really going to be your only increased cost. We do have a significant battery life on these, up to 10 years with normal usage. It all depends on how you use them. So other than having to purchase batteries when those start to go down, there shouldn't be really any other additional maintenance cost.
Okay, and you're talking about the batteries. Someone did ask, how are your products powered? So I guess, does that answer the question fully? Battery powered?
Lithium, sorry, I didn't mean to lithium metal batteries. So they are long life batteries.
Great. Okay. When a leak is detected, can it get shut off automatically, or can it?
I think I'll take this one. I assume that this question is about the remote disconnect meter, because that's the only valve that we actuate right now from Centrex. It is not automatic. So if we can detect a leak on the service side of the meter by tracking, and Centrex does this, it tracks flow rates throughout the day, every hour. And if I can't remember exactly what the threshold is, but for a number of consecutive hours, there's not a zero flow rate, it throws a flag and says, hey, there might be a leak on the service. We do not automatically shut the meter at this point. That's logic we could implement if there was a use case for it. But for the most part, the workflow around that is that a flag says there's a leak on the service, and then the customer service department would contact that customer and inquire if they do have a leak in their house somewhere. And then I think, then there's a choice as to whether or not the customer service rep can shut the valve. So.
Okay. Do you have any capability on the wastewater side, for example, detecting sewer overflows?
So in Centrex right now, we don't have any sewer-specific modules. Maybe I'll go to Harold, though, because I know we do have pressure monitoring applications on the sewer side. We don't do overflow detection, I don't believe. But Harold, maybe do you want to answer that? 'Cause I know that you've got some use cases for pressure there.
Yeah, Dave, I'll take that. We do have a few customers who are using the HydroGuard pressure monitoring systems in a lift station or in a wastewater application. It's not recommended. The design is not necessarily designed for that, but there are some case studies where customers are doing it. It's something that we would prefer to work with you as if you're a customer who's interested in trying to do something like that. We would like to work with you more directly than to just let you run out on your own with it. And so if it's something you're interested in, if you contact myself or anybody on this call, they can direct you back to me and we can work with you more direct.
Great. Okay. Can the HydroGuard pressure monitor be modified to work with a fire hydrant that has a check valve immediately upstream of the fire hydrant?
That's an interesting question. Check valve immediately upstream of the fire hydrant. Answer, I don't know until I'd have to take a look at the specific design. Harold, I don't know if you'd answer that differently than me.
If you have a control valve upstream of the hydrant, your control valves typically will have a pilot on them, and your piloting system takes up 2 ports on that valve. There's typically 2 additional ports on the other side of the valve. And those 2 ports can allow you to do, like a pressure reducing valve, for instance. You can tap into those 2 ports with a 1/4 inch MPT sensor that is part of the pressure monitoring system. And you can actually measure both upstream and downstream pressures from the same valve.
Excellent. Okay. So this may have been covered briefly regarding the battery pack. How long is it good for? And do you have the variance in pressure over time?
Yeah, so Patrick, I'll just take that one quickly. But target under normal operation is 10 years. If you set the thresholds really tight, then the device communicates more with the server and uses more battery. So I think if it's in like really aggressive settings, it can be as low as 3 years.
Okay, great. Let's see. Will the pressure respond quickly if the hydrant is activated for authorized or unauthorized use?
So the specification, I believe, is that it responds to a pressure change, a pressure threshold cross within 2.5 minutes. And so if I don't know if that meets your definition of quickly, but you do, when we've done these field installs, we test at the beginning, we do flow tests. When you open the fire hydrant up, that pressure drops really quickly, and you get a pretty immediate, indication within 2.5 minutes of that happening. So
that seems pretty
if I
darn
could
fast.
add on to that just a, if I could add on to that just a little bit, hydroguard pressure monitoring systems, both in the hydrants and the standalones, have event notification built into them. So the customer will preset a critical high, a critical low, critical warning high, warning low zones, so that if the pressure threshold crosses into any of those zones within 2.5 minutes or so, the device will send out both a text message and an email, depending on what the customer is requesting.
Great. Okay. What are you using for leak analysis? Are you using or plan to use AI to detect leaks?
Hannah, I'll take first crack at this, and then you can fill in if you want.
Perfect. Sounds great.
We use it's a correlation algorithm that does cross correlation between two channels. We do have machine learning projects in place to improve our ability to detect leaks. They're not deployed yet. It's really just research activities. So I think short answer is yes.
Okay. Should we move on? Can the HydroGuard pressure monitoring system sensor be retrofitted, and how easily, to an older Centurion hydrant?
I can take that one, Dave. Yes, it can be retrofitted fairly easily. I think our installation takes around 45 minutes. That's just to pull your main valve assembly out, replace the stem with our pressure sensing stem, and install it back in the hydrant. It's pretty easy to do. If you're familiar with how to hydrants floor around, you can put them in pretty easily.
And that's Patrick. That's anything back to it's a Mueller Centurion back to 1975, right?
Correct. Yep.
Okay. Along similar lines, is this model available in U.S. pipe hydrant range?
It is not currently available on the U.S. pipe.
You could put the leak detection technology on the U.S. pipe range, but not the internal HydroGuard pressure monitoring technology.
Perfect. And as we get down to the end, I guess this is appropriate now. Who contacted Mueller for more information?
Well, we've got Harold Mosley on the phone, and so if you've got any inquiries regarding pressure monitoring, he's absolutely the right person. But I think I would probably direct you to your local Mueller contacts as well. So if you do have your regional contacts in the area, that would probably be the first place to go. And there's a long list of names that I'm not going to remember all of for there. But I think any of us that are here in this presentation would be happy to field any questions you have and point you in the right direction if you don't have another contact at Mueller to reach out to.
Excellent. Okay. Well, thank you so much. Unfortunately, that is all the time we have for the Q&A. So thanks again to all of our presenters for their insights and their expertise. All the audience questions have been logged, even those we couldn't get to today, and we'll pass them along to our presenters and Mueller for potential follow-up. We'll also receive an email in the coming days with a link to the full presentation. So thanks again. Thanks, everybody, for listening. And please, everyone, enjoy the rest of your day.
Thank you.
Thank you.